Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your friends. That's the only way you can keep me going, inspired and refreshed. And if my videos are important to your studies, then don't forget to subscribe. By the method of least work, determine the member forces. E is 200 gigapascals and cross-sectional areas for top chords and bottom chords 1875 mm square, interior diagonals 625 mm square, and interior verticals 1 to 50 mm square. So here we go. This is the figure. This truss is statically stable and indeterminate to the second degree internally. Externally, it is determinate. There are only three support reactions. So we select the redundant forces to be one of these diagonals per panel, and we put the results here by statics. I will leave to you the results of statics by analysis. I will put the forces in terms of redundance, especially for these panels here, and of course for the others I will leave that to you. So the reaction here is 112.5 kilonewtons. If you sum up moment about E, horizontal reaction is 0, of course. Then if you sum up moment about A equals 0, that's an easy job. Then you can also find the reaction at E, which is 67.5 kilonewtons. So the slope of these diagonals is 12 horizontal, 9 vertical, so we can reduce that to 4. 12 divided by 3 is 4, common factor is 3, then 9 divided by 3 is also 3. So that's why we have 4 horizontal, 3, and 5 vertical. So beginning at joint A, summation forces Y, you will get the force or stress of member AH to be negative 187.5. And that's the final member force of AH. Summation forces horizontal, you will get 150 kilonewtons. Then remember that the assumption is we always consider the bar force or member force to be in tension. Then you may proceed to E, summation forces vertical equals 0. You will get negative 112.5 for EF. That's the final member force. And for DE, it's positive 90 tension kilonewtons. We then proceed by choosing BG as one redundant. The other redundant force would be DG as shown. Let's denote that with Q. Then we proceed to joint B, summation forces vertical, so that you can express BH in terms of F, negative 0.6 F plus 90. I colored it with yellow because vertical chords have different areas, cross-sectional areas. For the diagonals, let's have blue. Then summation forces horizontal, you can solve BC, negative 0.8 F plus 150. So this is the color for top chord members and bottom chords. Then we proceed to joint D, summation forces vertical, you can get DF S of D at negative 0.6 Q. Then summation forces horizontal, you will have CD negative 0.8 Q plus 90. Then we then proceed to joint H, summation forces horizontal equals 0. No, vertical, summation forces vertical equals 0. You will get CH equals F plus 37.5. Then summation forces horizontal, you will get GH negative 0.8 F minus 180. You then proceed to F, summation forces vertical, to get CF in as Q plus 112.5, and summation forces horizontal is equal to negative 0.8 Q minus 180. You then proceed to joint G, summation forces vertical, to solve for CG, and it is negative 0.6 F minus 0.6 of Q. So you then check summation forces horizontal if it is really 0, and definitely it will be 0. I already checked it. At C, we also check equilibrium summation forces horizontal if it is 0, and summation forces vertical for to make sure that the result is in equilibrium. So we proceed by tabulating. So these are the colored members, so that it's easy for us to set up summation forces, summation of S, partial of S with respect to F length over AA, because they have different areas, as well as the second one. There are two equations in two unknowns. So for BC, the force is, you just transfer it, then derivative negative 0.8. With respect to Q0, the length of BC is 12, then S for the product, and here it's 0. Then for the final member force later, BG is F, derivative is 1, 0 here, then the length is 15, square root of 12 square plus 9 square. Then this is 15F, 0 here. And BH is this one, negative 0.6F plus 90, negative 0.6, 0. The length is 9, then the product here, then 0 here. CD, negative 0.8Q plus 90, negative 0.8, 0, because this is in terms of Q. Then here, negative 0.8, the length 12, then 0 here. Here, the product in terms of Q and the constant. Then CF, Q plus 112.5, partial derivative with respect to F0, 1. The length is 15, then 0 here. The product would be here in terms of Q and the constant. CG, which is this, negative 0.6 F, negative 0.6 Q. So here negative 0.6, here negative 0.6 also. The length is 9, then the product here, then another product here. It's the same. CH is F plus 37.5, so 1, 0. Length is 15, then the product here, then 0 here. DF, negative 0.6 Q, 0, negative 0.6. The length is 9, 0 here. Here is the product in terms of Q, 3.24 Q. DG is Q, 0, 1. Then the length is 15, 0 here, then 15Q here. Then FG, negative 0.8Q minus 180, 0, negative 0.8. The length is 12, 0. Then the product here, 7.68Q plus 1,728. Then finally GH, negative 0.8F minus 180, negative 0.8, 0. Length is 12, product here, then 0 here. So finally, we have to combine. So first, let's set up this equation combine the same colors for F. So we have 15.36 F plus 288 for the pink color divided by area 1875 E. So this is summation of S, parcel of S with respect to F length over AE. Then for the blue ones, 15F, 15 so 30F plus 562.5 over area 625 for the diagonals, interior diagonals, E. Then plus for the yellows, 3.24 plus 3.24. Then there is Q, take note. So 6.48F plus 3.24Q minus 486 over area 1250E. Then equate to 0. Then combine the F's further with Q. Set up the first equation, cancel E, cross multiply E with 0, so 0. Then this is the first equation, 959 over 15625F plus 81 over 31250Q equals negative 831 over 1250. Call that equation 1. Then this one, this column, you add over AE. So let's have the pink ones, magenta, 15.36Q plus 864 over 1875E. For the blue ones, 30Q plus 1687.5 over 625E. And for the yellow, 3.24F plus 6.48Q over area 1250E equals 0. Again, cross multiply E, so 0. E will vanish. Then combine F's and Q's, so 3.24F over 1250. Then the Q's combined, so we have 81 over 31250F plus 959 over 15625Q equals negative 3951 over 1250. Solving these two equations simultaneously, we get F, which is equal to SVG, negative 8.672 kilonewtons, while Q, which is equal to STG, is equal to negative 51.133 kilonewtons. Then for the other members, so you just substitute F here, negative 0.8 of negative 8.672 plus 150. Then we put the final member force here in kilonewtons, so you'll get 156.938. For BG, it is F, and it is negative 8.672. For BH, negative 0.6 F plus 90, negative 0.6 of negative 8.672 plus 90, so 95.203, and so on and so forth. So you know already how to substitute it into this column here. You put the answers here. So for FG, negative 139.094 kilonewtons. Finally, for GH, negative 173.062 kilonewtons. And for the other members like AB, 150 kilonewtons. For AH, negative 187.5 kilonewtons. For DE, positive 90 kilonewtons or tension. Then EF, negative 112.5 kilonewtons. So that's it for this problem. There are two redundant forces. For your experience, then we have the complete analysis for the member forces.